talk about properties of perpendicular bisectors and angle bisectors. Then we're going to talk about properties of medians and altitudes. Okay. All talking about triangles. A lot to write here, so I'm going to pause and let you get caught up, and then we'll try to make sure you understand. In case you're at home copying this down, notice we had a correction, typo at a point. First of all, we have to make sure we understand what concurrent lines are, because all of these other four situations we're going to talk about later today have concurrent lines. And concurrent lines just simply means that we have three or more lines that all meet at the same point. Okay, the reason we say three or more, not two or more, is because if you just have two lines and they meet, they have to meet at the same point, right? If they cross, and where they cross, that's the point. But if we have three or more lines, they could just look like this, and they don't all meet at the same point. Okay? So concurrent means that all three lines meet at the same point, something like that. So those three lines would be concurrent because they all meet at the same point. Okay? RJ and Easton, you with me? Okay. Point of concurrency is the name of that point. Okay, where the three lines meet, that point is called the point of concurrency. That's the point in which they meet. And so you've already copied this down, but it says perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. Okay? So if we have a triangle and we construct all the perpendicular bisectors, and I'm not going to let's take this one. I'm going to leave myself much room here. Let's look at this right here. And I'm just going to pretend that I am constructing the perpendicular bisectors of these segments, okay, of the sides. So if I do that, I get that, okay? Now, in one of the homework questions yesterday, they actually asked you to do that problem. I think it was number 33. And they said construct. And I said, well, to my other class, you guys didn't get that far or whatever, you didn't say anything. But in the other class, I says, you don't actually have to get a compass and construct, but get a protractor and a ruler and measure and draw the lines, make sure that they are perpendicular, each one of them, and make sure that they pass through the midpoints, okay, of the sides. And they'll all meet at one point, okay? Bless you. That point is called the circumcenter. That point right there is called the circumcenter of the triangle. Sometimes that point is inside the triangle. Excuse me. Sometimes it's not inside the triangle. In this case, it's not. Now what that would mean is, if I draw a circle using that point as my center, the circle will be circumscribed about the triangle. So just for kicks, let's see how close we were. Okay, not real close. That's what happens when you make things up. Anyway, what would happen if you did it accurately and not just freehand like I did, is that this point would be on the circle, this point would be on the circle, and this point would be on the circle. So I could try to move that a little bit. And that's pretty close. So if I had if this program would save the center, I'd find out that the center was probably closer to over here. Okay? That's where the point should have met. Alright? That's what happens when you construct the perpendicular bisectors of each of these sides. And so if we expanded on that homework question from yesterday we probably said, well, all three of those lines meet at the same point. But today we know that when they meet at that point, it becomes the center of the circle, which can be circumscribed about or around the triangle, which means it'll pass through every one of the vertices of the triangle. Okay? Circumcenter. And this will get confusing. So at some point, you're going to have to understand that the perpendicular bisectors of the sides create the circumcenter. Okay? I don't know if you need to write it down that way or what. At the end, maybe put them all together, list the 4 scenarios. Okay, the next one is the bisectors of the angles of the triangle. And they are concurrent at the point equidistant from the sides. So if you're watching this at home and I forgot to slide this down and let you pause and copy it down, then just pause it now. Anyway, if we construct the angle bisectors, let's try this again. We'll take another triangle. And if I draw the angle bisectors now, so we'll I shouldn't have stopped that right at the side there. Okay, so we get this. Okay? Now what I tried to do, and I just did it freehand, so it's not totally accurate. Those would be equal, these would be equal, and as I look at them from this side, they really don't look equal. They stand out in front, they don't look quite as bad. But anyway, that's the idea. You make sure all of those are equal. What we get then is called the centroid. And the centroid says that we can draw a circle that is totally inside the triangle. And so it would look like that. Okay? And so, as I thought, my center was more over here. Look a little more like that. Okay? But anyway, if we constructed all the angle bisectors, remember back in chapter 3 we did constructions of, in chapter 2 I think, we did constructions of angle bisectors and we did constructions of perpendicular bisectors. And if we applied those notes, we could construct these angle bisectors right here and down here. Whoops, I need to grab that. And over here. Okay? And so anyway, when we did that, we would find the center where the 3 lines meet. That point of concurrency right here is called the end center. Okay? That's called the end center. Excuse me. And so, so far now we have 2 scenarios. We have perpendicular bisectors created the what? Nice and loud. The perpendicular bisectors created the what of the triangle? The circumcenter. That made a circle that went around the circle, right? About the circle. And then we just talked about the angle bisectors create the end center, and that creates a circle that goes inside, and it just touches each of the sides at exactly one point, right there, and right there. Okay? That's what we get from that. All right? Next page. I'll pause this so that you can copy it down. sorry if you're at home, you missed the whistling symphony that we had going. This is the one we're going to talk about the median of a triangle. And it's a segment whose endpoints are the vertex, are a vertex, and the midpoint of the opposite side. So in this picture here, this median, here's one endpoint, it's this vertex D, and this endpoint J is the midpoint of the opposite side. And so I probably should have marked that like that to indicate that J is actually the midpoint. And since G is the midpoint, I should probably do this. And H is a midpoint, so I should probably do this. Okay? So H, J, and G are all midpoints of these sides of the triangle. Okay? So now, what's important about it? Well, the three medians will always be concurrent at a point that's 2/3 the distance from the vertex. What's that point of concurrency called? What's it called? What's that point of concurrency where the three medians meet? The centroid. Okay? I didn't write a separate statement in this case, I just put it in the picture. It's called the centroid where the three medians of a triangle will meet. They always have to meet inside the triangle because their lines, segments are just totally inside the triangle always. Okay? And so that point has to be inside. That does not create any special circle. It doesn't make a circle outside, inside, around, next to, anywhere. Okay? What it does do is that point breaks up these medians. For example, let's look at this one. It breaks that median up into two segments that are 2/3 and 1/3 of the whole. So if this line DJ was 9, so if DJ is equal to 9, sorry, DJ is equal to 9, then how far is it from D to C?
6.
And how far is it from C to J? 3. So if this is 1/3, then this is going to be 2/3. So if this distance here was 1/3, then this distance is 2/3. And so if you took the total distance 9 and times it by 2/3, you should get 6. If you took the total distance 9 times it by 1/3, you should get 3. Okay? Now, here's something a little different. What if they told you this distance here was 2? Then how far is it from F to C? If from C to H is 2,
4.
the question is how far is it from F to C?
4.
Someone said 4. Any other thoughts?
Wait, 6.
6. Which segment is CH? Is it the 1/3 or the 2/3? It's the 1/3, right? It's the shorter of the two. So it's the 1/3. And so FC is going to be 2/3. And so if 1/3 is equal to 2, how much is 2/3 going to be?
4.
4. If this is a third and this is a third, then 2/3 is 4, right? Okay, so this is 4. Then the total distance F to H would be what?
6.
6. My 4 looks like a 9. Oh, and now it looks like nothing. That was 2, this is 4. And then the total distance is 9. I'm sorry, 6.
Ah.
I talked myself into it. The total distance F to H is 6. Okay? Now, what if EC is 8? What if EC is 8? Let me create a little more room here. Distance from E to C is H. We need to know the distance from G to C and from G to E. So if E to C is 8, Nick?
The G to C is 4, and the total distance is 12.
Okay. So we're saying if the 2/3 was 8, then we split that in half, 1/3 would be 4, right? And so GC is 4, and then GE would be the total, which is 12. Okay? I'm not going to promise they always give you nice numbers like I just made up for you. Sometimes you may end up with some other stuff, and so you just have to remember that. And so anyway, the medians, it creates the centroid. So again, to review, because there's 4 of these coming at you today, and you have to remember them, and they're certainly going to ask you questions about each of the 4. The first one was the perpendicular bisectors of the sides created what point? Circumcenter, and that made a circle that was circumscribed around the triangle, or about the triangle. The second one was the angle bisectors that created the what? The end center, and that created a circle that was inside the triangle and just touched each side exactly once. And then the third one are the medians, and the medians, again, that might be a new term for you. That connected the a vertex of a triangle to the midpoint of the opposite side, and when you have all 3 of those medians, you get what is called the centroid, and that breaks the medians up into 1/3 and 2/3 the length of the whole median. Okay? Now don't be afraid this weekend to pull this up and watch it if you get hung up on some of this stuff, because we're throwing a ton of information at you today. So here's the last page. We're going to talk about the altitudes. I'll pause so you can copy. There's another typo up here with 2 to the line. Just one more sentence here. That point of concurrency is called the orthocenter of the triangle. All right, here we go. An altitude of a triangle is a perpendicular segment from the vertex to the line containing the opposite side. There's 3 scenarios, 3 examples here. 3 examples of what an altitude can look like. The first one could look like this. So I just drop this line straight down, okay, from the vertex to here, and I create a perpendicular line on the other side. It may be at the midpoint, it may not. It just drops straight down so it's perpendicular, okay? Another one could be a side of the triangle. Could be the side right here. And another one could be dropped down so that it's outside, and you notice it's an extension of that line. So that's why this says the line containing the opposite side. It may not actually touch the opposite side. It will just come to the line that contains that opposite side. So this, I forgot I put that all together. This green line here, green dotted line, contains that entire side in it. Okay? So it contains that whole side. So 3 examples there. Now, the theorem that goes along with it, the lines that contain the altitude of a triangle are concurrent. That means all the lines that contain those altitudes will all meet at the same point. That point is called the orthocenter. And here's what you'll like about it. There's nothing special about it. There's no circles involved. There's no 2/3, 1/3. There's nothing special about it. It's just, that's what it's called when this happens. Okay? And so if I tried that with this triangle right here, we'll use these red lines. So if I draw this one, and if I draw this one, if I draw this one, okay, and I was trying to be very careful to make sure these are all perpendicular, and we already knew that one was. They would all meet in that point right there. Okay? So that point is called the what? Orthocenter. And we could try the same with this one over here. Perpendicular. Bless you. And these two are already perpendicular. And so this orthocenter is right there. Now this question on the test may want you to draw it on a coordinate plane and just identify the orthocenter. That probably is all they'll ask for. Okay? So if there's a test question on this, they'll want you to take this on the coordinate plane and make these perpendicular bisectors. And if we find where two of them meet, then what has to be true about the third one? Put that way, Ethan. If we find where two of them meet, what has to be true about the third one? What's that? It has to meet there as well, exactly. All three meet at the same point, then do I need that third line to know where that point is? No. If these two meet right here at this point, then the third one's going to meet at that point. Okay? If these two lines here meet at this point right here, then the third line's going to meet at that point. That's true on all of these four scenarios that we talked about. Okay? All right. I told you, I warned you this was going to be long-winded. That's it for today. Let me look at the assignment again, and then I might change exactly what I want you to do. Okay? So on the calendar, you see there it says 1 to 51 odds and checkpoint quiz 1. I am going to change that. So let's just do 1 through 23 odd and checkpoint quiz. Okay, so there's our assignment for the weekend. Try really hard to get that done before you come back on Monday. We will spend 2 days on lesson 4, not because lesson 4 is really hard. It's more so just to make sure we've had time to let all this digest before we slap the test on you. Okay? So it's to build in another day. And I do have assignments for both days. I might modify them a little bit, but we will certainly have assignments both days. So it's not just a total work day. So be prepared for that. Try to get this done.